Let's work on graphing these exponential functions. Our first one, we have f of x is equal to 2 to the x plus 1. This guy is an exponential function, not just because I told you we are doing exponential functions, but it is exponential function because our variable is in the exponent. If the variable was not in the exponent, we would not have an exponential function. But because it's an exponential function, we know the domain is immediately negative infinity to positive infinity. With our horizontal asymptote, remember that comes from whatever we add or subtract after the exponential piece. So we have 2x plus 1, but nothing is being added or subtracted outside of that base with the exponent, which means that we can put in a plus 0 and our horizontal asymptote will be y equal to 0. To calculate your y-intercept, remember that means plug in x equal to 0 and solve. So we're going to have 2 instead of x plus 1, we'll have 0 plus 1, which gets us 2 to the 1, and 2 to the first power is 2, which means that we just found the ordered pair 0, 2. Okay, the thing about exponential functions is that they get either really big really quick or really small really quickly. Okay, so when we're asked to find 3 additional ordered pairs, we need to be careful. We're not going to be plugging in, let's say, 10, because if we did that, we would have 2 to the 11th, which is 2048. Do you really want to try to graph that? I know I don't. Okay. So when we're plugging these in, we're going to stick to smaller x values. You can pick any values you want, but here I'm asking at least one of them to be negative. So if we do an XY chart, pick any 3 x values you want other than x equal to 0, because we already did that. So let's see what happens when we plug in -1. We already plugged in 0, so let's plug in 1 and 2. For x equal to -1, we would have 2 to the -1 plus 1, which would get us 2 to the 0, which is 1. So the ordered pair we just found is -1, 1. Let's see what happens when x is equal to 1. We would have 2 to the 1 instead of x plus 1, which gets us 2 squared, and 2 squared is 2 times 2, which gets us 4. So we just found the ordered pair 1, 4. Let's go ahead and plug in x equal to 2. We would have 2 to the 2 plus 1, which gets us 2 cubed, which is 8. Remember, it's 2 times 2 times 2, not 2 times 3. Meaning we just found the ordered pair 2 to the 8th. And it's going to keep getting bigger the higher that you go with your x's. Okay? By the time that you hit x equal to 5, you'll be at 64 for your y value, which is why I said that we should keep it smaller. All right, so when we're doing the range, I know if you watched our previous videos, we graphed it and tried to figure out what was going on. But remember, your range is always one of two options. It's either negative infinity to your horizontal asymptote, or it's your horizontal asymptote to positive infinity. Here, our horizontal asymptote was 0, and our numbers were going up when we plugged in the y values. We went 1, 4, 8. So we're getting higher and higher above the horizontal asymptote, which means our range is going to be 0 to infinity. We just said that the function keeps getting bigger as we plug in values that are higher in our x's. But let's go ahead and graph this. That may help you figure out whether or not our function is increasing or decreasing, because visuals are always nice. So we found the y-intercept was 0, 2. Going to start there. We found negative 1, 1. We found 1, 4, 2, 8. If you would have plugged in 3, you would have gotten 16, which would have been off the charts. So if we connect these ordered pairs, we're going to apply that. And you do need to have your horizontal asymptote with a dashed line and go ahead and label it. Okay, and so from left to right, we can see that our function is increasing. It's when it goes down from left to right that we are decreasing.